might have been recording for a little while and didn't realize it. But I am. All right, so I'm gonna do, can you see my screen?
Yes, ma'am.
Okay, so I'm gonna do one that shows you compute the volume in cubic yards between the highest and lowest contour lines. And what it would kind of look like is, if I was doing contour lines, I'm gonna do a little drawing over here to the side. This would be like 100, and then as it got bigger, this would be one elevation 110. And we would get an area, and this would be 120. And then as it gets bigger, it's just like this model right here.
So this one right here will be like a depression, right?
No, because
of the center, you have the lowest.
it's 100 is the smallest area. So here's like the smallest area.
Oh, you're talking about the area, not
Yes,
the other.
so the area in square feet. So
Oh, okay.
let me just put my camera on for just a second. All right. Nope. Go back over here a little bit. And you can see. So if I was trying to look at area on contours, like if this was 100 foot, or actually, my numbers go from what 100 to
120.
So they go up. So it would be a depression. It would be kind of like upside down.
Yeah.
So what would happen is if I'm looking at it, it looks something like, these are the contours here. What are our contour intervals? Every 5 feet or 10 feet?
Every 10 feet.
Okay. So it kind of look like this. And this would be my 100. And the area for the 100, what do I have down for the 100?
You just had 100.
I had 100.
Yes.
And then I had like 101,
110.
110, 120, 130, and 140. And you would get the area of the contour. So these are the areas, and it would be like it's getting bigger as it goes up. If this was a peak, then they're getting bigger as it goes down, like this would be 120, it's getting bigger as it goes down. But what we're doing is we're getting the area of that contour, and we're going to take an average of the two areas, and then we're going to divide it by 2, and then we're going to multiply it by the distance between the two contours. So this is on some of the homework. It's on that online test, and it's going to be on the final exam. So it would be your area of the contour for 100, which is 105.
Now, we cannot see the screen.
Oh, I'm glad you said that. See it now?
No, we can't.
Okay, good. So it'd be the area of 105 plus the area at 300 divided by 2, because we're going to take the average, and you multiply it by your contour spacing. So the contour spacing is the difference between the contours. These are every 10 feet. You may have one that's done every 5 feet. So just pay attention to what the contour intervals are. I had y'all draw contours every 2 foot when we in the online for module 4. So all we have to do is flip over. I've already got all these worked. So if I do area for 100 plus the area of 110 divided by 2 times 10, and I'm going to actually put that in, I'm going to keep it in square feet. It says it's going to want the volume in cubic yards when we get to the end. So I'm going to wait and just divide it by 27 when I get to the end. So it's 105 plus 300. We take an average divided by 2 times 10. 1,025. And then I'm going to go to the next two and do 306.75. So I've seen some where they've actually just did the first two, they did the next two, the next two, and the next two, but they've missed all the areas in between. So you've got to get the area. We're trying to figure out a volume from all the way from 100 down to the 170. So if I take 300 plus 675 divided by 2 times 10, it's 4,875. I think one of the problems in the textbook, they either gave you, they might have gave you even the, I'm not sure, did they, you had like this. Is any of your charts that are set up like this. So the next one is going to be 675 plus 900 divided by 2 times 10.
I don't know why you gave me 2025 for the first one.
It is 2025.
Oh, okay.
Right here. See it?
Oh, okay.
2025. You're right. And I might just say, you know, this column is square feet, so I don't have to put. All right. Next one is going to be 900 plus 1250 divided by 2 times 10. I'm going to go ahead and when I'm here, I'm at 10,750. This next one, I'm at 15,250. And last one. So there are all of my areas. Actually, that's cubic feet. Because this is actually in square feet, sorry. I would say cubic feet right now, up at the top. And then I want to add them all together. That's a CF, that looks really bad. I want to total them all together. Now, if I total them all together, I'm going to get a volume of 95,650 cubic feet. And I want this in cubic yards. So I'm going to divide by 27. To put my cubic yard. So if I divide that, I've got 35,000. Pretty cut and dry.
So that's what I have to do on this one then.
Mm-hmm.
2612.
So you would just take an average of your two areas and multiply that by your distance between the contours. So the homework, which one was the homework? What did the homework? Is that the one you were asking me about the homework?
Yes, 2626.
Mm-hmm.
Now, the column all the way on the right, that starts with the 2025, we add all that. And then,
Yeah, I added all those together and I put them on the second page. So you're 26. Yes, so you would have your areas, you would set it up in a chart form. So you could put, for that particular one you're talking about, so once you get these, I totaled them all up on the next page, added them all together, and that was my total. And then I just divided by 27. And that would be your answer. Okay, so I'm just going to go one page over and say if you're doing your homework ones and you have 26, I would do one of that, 120, 125, 1030, 1035, and 1040, like that. And then I would do my areas here. In your area, and that's in square feet, I would put, that's what, 1850? So I would say 1850 plus 1957 divided by 2 times 5, because the distance between here is 5. And then I would get that answer. This is problem 26, page 797.
So,
I just put it in the chart form, just like I worked that other one. I did it like that. Just put it in. I put the areas in line. That way I can take it's easier for me to take the average of the two areas when I have list it like this. And then when you get your area, and I would put, this is in cubic feet.
But this one asks for, acre foot.
Okay, so what we would do is, once we get it in cubic feet, that is 1 feet deep by 43,560. So I would change, we will change our, when you total it up, you'll have it in, so acre foot is 43,560 square feet in an acre. An acre foot is 1 foot deep. So when we get our answer, you just divide it by 43,560, and that'll be your acre foot that you have. Because 42, acre, you see it right, acre foot is 43,560, and it's 1 foot deep. So that times 1 is itself. So once you get your total in cubic feet, you should be able just to divide it by 43,560. Answer to those. I do. When you get to the end and you summation it and divide it by 43,560. I don't have each one. We had already divided each one by 4360. Once we got that, we went ahead and converted it to acre foot by dividing this answer. Let me go ahead and put it back in. So like for that first one,
So the first one will be 3806.
you did 1850 plus 1975, or 57 divided by 2 times 5. 9517. And if you wanted to go ahead and convert it to acres by dividing it by 43,560, it would be 0.218. And then you would just total up in your last column. You should end up with, for your end, at about 1.23 acre foot, if you total them all together. That should be your end answer. Is 1.2278, depends on how you keep it out. That's about, when you total them all, that's what you should about get. So I think on, let me see on the final exam, what I asked for. I have this on the I asked for this on that test for the volume in Earthworks, and I just asked for it in cubic feet, so you wouldn't have to change it over. So you don't have to convert it to cubic yards. I'm just looking for cubic feet for the online test. I have it due next Monday or Tuesday at 12. But after we finish today, you should be able to work anything on there. I've only had one person actually complete it, but you can go in and print it out. The final exam, let me see what I'm asking for. I'm probably asking for it in cubic yards. I did, I asked for it in cubic yards, so you just want to make sure when you do the exam, it'll be like the one I just worked, where we're going to divide it by 27 at the end, because that'll be the answer I'm looking for. And the problem online that you have the test, it just asks for it in cubic feet, but in the test, I asked for it in cubic yards, so you divide it by 27. Questions? Does that make a little sense now?
Yes, ma'am.
Okay, so I'm going to just save this one. This is going to be go in and save it as a PDF. All right, this is the next problem I'm going to do. This is one that was like the online assignment. I saw some people do some silly mistakes, and I saw some that didn't have a clue what they were doing. So you've got a grade in there now for this one. If you want to correct your mistakes and resubmit it, showing your steps and your correction, and maybe tell me what you did wrong, then I'll give you 100%. So you'll have to fix your mistakes. Some I saw them had the right formula and had the wrong answer. If your two volumes aren't close, vis-a-vis and vis-a-vis aren't close, then you know you kind of got a problem anyhow. All right, so we're going to do, this is below are the cross sections, station 26 and 27. So I know they're 100 feet apart. The road bed is 28 feet. You want to calculate the area of the two cross sections using the 3-level section. All right, so I'm going to flip over. And there is the formula that I'm going to use. All right, get started. I don't have this work. Okay, so I'm going to do the 26 first. $11.1 is my C. So this is what the C is. Doesn't mean it's a cut. That's just, that means center is what it stands for. This would be your distance left. This is distance right. This number we use is our height left, and this will be our height right. Looks like that. And our road bed for this particular one is 28 feet. So that's my B. Okay. Okay. 29.9 plus 24.6. And this is all over 2. Plus my road bed, which is 28, 12, 2, plus 8.8 divided by 4. So for this particular one, I got 449.475 square feet. And that's my area of 26. Okay. I'm going to do my area of 27. I got 398.95 square feet. So when I want to do my B sub E, it'll be area 1, 449.475 plus area 2, L is your distance in stations. So the distance between these two is 100 feet. Not always is 100. You'll see some that are 75 feet wide. So look at your station numbers. That's why I say don't make a mistake and assume everything's 100. I think the one online was easy because it was, I think it was 100 feet. But let me look at. That one's 100, and I probably will say the final exam might not be 100. So pay attention to your stations. If it's like 26 plus 00 and 26 plus 75, that would be 75 feet. So just pay attention to the difference between the stations. And the L is always going to be the 2 outer ones. So I need this. So L is 100, and the answer needs to be in cubic yards. So you got to divide by 27. I think I saw the online one, some didn't convert it to cubic yards, but it says what is it in cubic yards. So make sure if you didn't do that right, to put it right. Pay attention to the units. I got 1571,000. cubic yards. That would be the answer I'm looking for, V sub E. Now, V sub P is different. It uses L, and then it's area 1 plus 4 times area in the middle plus area 2, and then divided by 6 times 27, which is a constant. I saw some that had no idea how to get the area in the middle. It's not just taking the average of the two areas. You have to decipher what the area in the middle is going to be. So let me take off these to give room. I want to look at this one right in the middle, 26 plus 50. I'm going to take the two cuts, the one at both at 0, I'm going to add them together and divide it by 2. So to get the one in the middle, it's 11.1 plus 8.7. We're going to divide by 2. So that would be 9.9 over 0. Now you got to do the same thing on the left. You have to do the two heights left. And then you also have to do the two distances left. So if I say 29.9 plus 33.8 and divide that by 2, then this should be 31.85. And the 10.3 plus 12.2 and divide that by 2. So that would be my cross section to the left. And then we're going to do the same thing on the right. Because if you're just taking the area of the two, you're just doing the averaged in formula. You're not actually figuring out what the area in the middle should be. If you're just taking what you got for the two and then making an average, then you're going to get the same form. You should get the same answer as your averaged in. All right, so now on the left side, I've got an 8.8 and a 6.3. So that's 15.1 divided by 2, 7.55 for my height. Yep, and then my distances are 31.2 and 24.6. If I take those two and divide it by 2. If you want to take your online assignment and fix it, then I want to see how you do get this. Because I saw some didn't take that step. Now, I've got to plug those in and do an area in the middle. Let's see if I can. That's fine. So I'm going to do area in the middle. I'm going to put it over here. So it's 9.9, 31.85 plus 27.9 all over 2 plus 28, 11.25 plus 7.55 all over 4. And my area in the middle for this one would be 427.363 square feet. Okay, so now I'm going to go back to this formula and sub in. So V sub P equals 100. You want to make sure you do the 100 between, the length is from the outside to the outside. Area 1, 4, plus 4 times area in the middle, plus area 2, all over 6 times 27. That'll put our answer in cubic yards. When I solve for that, I got 1578.936 cubic yards. And there's some difference. So where that would make a difference at is if you were in rock, something that was very expensive, and it was very expensive, and you just, 9 cubic yards. Dump truck usually holds 10 cubic yards. So think about out of 15,780 cubic yards, 10 cubic yards really is not much. So when we're working with volumes ourselves, typically, we're not having to do the volume by prismoidal. The only reason I showed you volume by prismoidal is that you will see that on examinations. I've seen it on the surveying one. I've seen it on, I know it's been on the PE, professional engineering, so doing a calculation by volume by prismoidal. All right, good with that one? That would be the 2 answers. So let me go back. So I wanted the answer, actually vis-a-vis and vis-a-vis, that would be the second part of it. Would be the areas. I am going to save this one. This one. I'm going to call it cross section, y'all know what it is. All right, the last one is a bar pit. Now, I haven't even done this in class. So this was the online handout that I gave you. If not, it's actually in Blackboard. And what happens is we can lump similar ones that have the exact same shapes, like, get my notes. So I can see this first, second, and third one are all 25 by 15s. 15 at the top, because you see the shapes. I've already had the shapes in there. Now, instead of having to take each one and break it down, what you would do is what happens is they came over on the ground and took their rod and measured down in there, and they read 6.4 on that rod. What they're essentially doing is adding all four corners up, adding them together and dividing them by 4. And getting an average, and then timesing it by their shape. So if I did 1, I'll just do 1 like that. If I did 6.4 plus 6.6 plus 5.9 and divide it by 4, that would give me 7.175, and then I would multiply it by the area of the shape, which would be 15 times 25. That would give me a volume of 2690.625 cubic feet. But there's an easier way of doing this. So I have 3 that look the same, and then in this next group, I'm going to call this one 4, 5, 6, 7. All of these are the same, 15 by 15. And then I'm going to have 3 triangles. So I'm going to use this one as a triangle. And the triangles, I can show you how to do them. So I'm going to go, this is 12, 13, 4, oh, I have 4 triangles. So for the triangles, the area of a triangle is 1/2 base times height. And if I want to look at this triangle right here, 12, I would do 2.3 plus 3.4 plus the 5.6 divided by 2, or 3, excuse me, 3. We got 3 shots because it's triangle. And then 1/2, my base is 15, and my height is 25. So for that particular one, 2.3 plus 3.4 plus 5.6 divided by 3. Multiply that times I got 706. And that's a lot of work. So I'm going to show an easy way to do these, setting it up in a chart. So I'm going to flip over to right here. I'm going to go over one more page because I'm going to look at the first thing I'm going to look at is these 3 that are the same, that 1, 2, and 3. And what I'm going to do is I'm going to add the sum of my corner cuts up. And I'm only going to look at the ones, and here's how I'm going to do them. I'm going to circle them in it like an orange, and then I'll show you how I'm going to do them. Let's do yellow. So 1, 2, and 3 is all I'm going to look at, and I'm going to go in order. So typically when I write the figure number, it's normally I'll say A, D, E, H. But I've got to get all of them. I just kind of trying to tell you which shape it is. So 6.4 would be the first one. And then I've got to add the 6.6. But since I'm trying to do the sum of the corner cuts, and I'm trying to do those, I have to look at how many sides that it touches. So actually this 6.6, it touches the 1 and the 2. So I need to add it in twice. And then whenever I go to the 6.7 number, it touches 2 and 3. So I have to add that in twice. Now 2.3, because I'm not concerned with the triangle, it's only going to be one time because it only touches 3. I'm gonna like isolate 1, 2, and 3. I'm going to go over here and just isolate it so you can see how you isolate it. You don't even want to think about it. You just want to think about these. So my sum of my corner cuts, I would start with 6.4, and I would say plus 6.6. I'm going to just multiply it by 2 instead of putting 6.6 in there twice. And then I'm going to say plus 6.7, because that touches 2. I'm going to say times 2. Plus 2.3, and I'm going to only list it one time because it only touches this one. And then I'm going to come down. You can either go in order or you could drop down to the 5.9. 5.9 touches 1. Then 9.8 times 2 plus 10.3 times 2. And then the last one is 5.6. So I would add all of those together. And then I'm going to put that in the chart. That's the sum of the corner cuts. I haven't divided it or anything yet. I haven't done anything. I'm just going to add that in. So that would be AD. I get 87. What was the size of 1 square? I just need 1 square. What's the size of 1 square? What's the area of just 1 square? 25 by 15. So in the next column, I'm going to do area shape 25 times 15. And the multiplier. If it's a square or rectangle, multiplier is 1/4. If it's a triangle, it's 1/3. So now if I say 87 times this should be 375. So I'll do 87 times 375 and divide it by 4, 1/4. I'm at 8,156.25. So see how easy that was to do if you can isolate it? Instead of having to take each one and go over here and do each separate one and then add them all together, I can isolate them. So I'm going to do the same for 4, 5, 6, 7, 8, 9, 10, and 11. So that's going to be my area E, I, P to T. So I'm going to come over here, back up one. I'm going to do those 4, or 8. These are supposed to be all the same size. These are our 15 by 15s. And this is So I'm going to do my sum of my corner cuts. So I'm going to do, start at the top, I'm going to do 5.9 plus 9.8, it touches 2. So I'm going to say times 2 plus 10.3 times 2 plus 5.6 times 2 plus 3.4. Going to go to next row. I'm going to start with 5.7. 5.7, it touches 2 plus 7.7. How many does that touch? How many squares does that touch that are look of the same? 1, 2, 3, 4. 4. Plus 5.2 touches 4. Plus 4.8 touches 4. And plus 4.2 touches 2. Then we'll do the last row. 4.6 touches 1. 4.2 touches 2. This one's 4.8. Plus 4.8 touches 2. Plus 5.1 touches 2. Plus 4.4. So if I add all those together, my sum of my corner cuts should be 188.5. So that beats us having to take every single square and figure out what the average is and then multiply it by length and width. We can just do our sum of our quarter cuts. Our area of our shape is 15 times 15. So it's don't make the mistake of thinking it's the overall big, because I've seen some that said it's 30 by, or yeah, 30, 15 and 15 together, and then did 60. It's not, it's just the area of one shape. So that's 15 by 15, which would be 225. So if I do 188.5 times 225, and the multiplier is 1/4 because it's a square or a rectangle, I'm going to have 10,603.125. And this is square feet up here. Now the 3 triangles, there's 4 triangles actually. Or we could, now there's 4 triangles. I've already done the first one. The 3, so here's how you would do that. I would add the sum of my corner cuts. So I'd add all 3 areas together. So if I'm doing the one that's, let's see what number I called that one, 12. If I add all 3 of those together, that would be, that's my DHI. That would be 2.3 plus 5.6 plus 3.4. That would be 11.3 goes here. It's 1/2 base time height for the area. So 1/2, and that's 25 times 15. And then the multiplier is 1/3 because it's a triangle. So I would have 706.25. Then I'm going to do next one, I, O, and N. N-O-T, I-O-N. So that would be the next one. And then I have a O-U-T. So 13's the next one. I-O-N. And then N-O-T, not. And then and it doesn't matter how you label it. I'm not I-O-N, I got to do that one, N-O-T, and then O-U-T. Okay. So for the sum of the corner cuts for I-O-N, that's that little small one. It would be 3, 4, 4, 2, and 3, 9. 3, 4 plus 4, 2 plus 3.9. 11.5. And 1/2 base time height. That is 7.5, and the height is 15. Multiplier is 1/3. I'm going to go ahead and do the sum of the corner cuts for the next one. And that would be I-N-O-T. That would be 4.2, 3, 9, and 4, 4. 0.2 plus 3.9 plus 4.4. 12.5. I'm going to double check my numbers. And then out. The last one is the bigger one, which is 3.9, 4.4, and 5.4. Let me double check them. So, oh, I see one put theirs together. They actually did the 11.5 and the 12.5, added it together and had 24. So somebody realized these two were the same. And then the last one is 1/2. 15 times 15 divided by 1/3. Then I just have to do the 2. So I've got 11.5 times 1. And then I would want a grand total. So I add all of those up. And you should get for your total, I don't know if I can put it down here at the bottom. I should get 20,000 429.375. If I need it in cubic yards, you would divide that by 27. That would be cubic feet. Finally, sand, it is on there. And I want it in cubic yards. So I take my total, and my answer would be cubic yards. So that's the answer I'm going to be looking for. So it's just a matter of setting up the chart. And looking for similar ones. Triangles, you're going to have to do them all usually pretty separate, but they did they actually put two of them together and did them all, added them all to the sum of the corner cuts, which they could have done that. It's 13 and 14 were the same. They did them separately. But instead of having to do each single thing, you can lump your squares together. Just remember to do the sum of the corner cuts, and to remember that you're going to isolate it and think of it as like this one, like I isolated those and did some of the corner cuts. That was the 8, and that was the 3. Questions? So this is the bar fit method. So our book talks about it, but it just doesn't go into detail. And I just showed you a quicker way of working the volume. We good?
Ma'am, can you go back to the page where you were like working the squares and showing the...
That one?
Yeah, that one.
Okay.
So like 5-7,
Mm-hmm.
for 5-7 you had it touches only 2, right?
Right.
For 7.7 you had it touches 4.
Yeah. It touches.
1, 2. Oh, I see that.
Yeah, that's, so it touches this one, this one, this one, this one. Oh, this yellow doesn't show up too good. Let me pick a different color.
4-8 you said it touches 4 too.
I got me a custom. Yes. So 5-2 does too. So 5-2 touches this one, this one, this one, this one.
And 4-8 touches 5-2.
Mm-hmm. It touches 4.
And 5-1.
5 right down here.
Yeah.
Touches 2.
No. I'm saying 4-8.
4-8 touches 4 because it touches this one, this one, this one, and this one. That number right there touches all 4 squares.
So it's not the square itself, it's the standard. It's a grid coordinate.
Mm-hmm.
Oh, okay.
And so you have to think of which ones that it touches.
Okay, I see it now. So it's the grid coordinate, that corner, okay.
Yes. So like if I'm looking at this 4-2, then that touches this square here. Like I can write them, I'm gonna count this as, what numbers did I?
Top and the bottom, yeah.
Yeah, what?
4-2.
Yeah, so it touches these 2. And then 4 is just by itself. And then I'm looking along the bottom ones, 5-1 touches both of these, 4-8 touches 2, 4-2 touches 2, and then 4-6 is by itself. Don't get confused to these top ones, because a lot of times they'll think, okay, it's, if I'm looking at the big overall, they think that 9-8 touches 4, and it doesn't. We're isolating the shapes. So don't get confused if you're doing this one to think that it's touching 4, because we're only concerned with the top part and the bottom part, because we actually included because it was included in here and it was included in here. But we want to only isolate the areas.
The equal areas, areas that are the same.
Mm-hmm.
Okay.
Mm-hmm.
Are we gonna be able to copy this PDF as, all these PDFs that you're saving as PDF?
Mm-hmm.
Oh.
Yeah, I'll email them to everybody. So let me save this and this. Go back in, save it as a PDF. Okay, so I should have 1, 2, 3. So I should have 6 PDFs. I did 2 on horizontal curves. I did 1 for vertical, and I did 3 for the volumes. So I'm going to go ahead and log out since I've done.